All right, listen. This is simply beyond belief. For just a moment, let's set aside all the bureaucracy, all the surrounding noise and chaos. Let's deconstruct this from first principles. A space telescope, a truly phenomenal machine, by the way, has aimed its incredibly sensitive sensors at a planet located 120 light-years away from us. That planet's name is K2-18b, and within its atmosphere, it has detected something utterly astonishing: dimethyl sulfide. So, what does that even mean, you might ask? Well, it means this: here, on Earth, on our own world, this complex organic molecule is produced exclusively, and only exclusively, by living organisms. Microscopic phytoplankton, those unseen laborers populating the vastness of our oceans, are its sole terrestrial source. There exists no known geological process, no conceivable form of exotic or bizarre chemistry that could spontaneously generate this specific substance on an industrial scale. This is not merely some random chemical trace. This is a biosignature, an authentic, undeniable fingerprint of life itself. And now, we are observing it there, on a planet that orbits another star, in a completely different star system. This single fact, it changes absolutely everything. It represents a fundamental tectonic shift in our entire worldview, a shift that compels us to explore, to strive, to one day journey there and witness it with our own eyes. When a subsequent, far more meticulous analysis additionally revealed traces of dimethyl disulfide, or DMDS, another compound of purely biogenic origin, the tomb-like silence from official space agencies was replaced by something far more unsettling than a simple restrained statement: the complete and utter absence of a denial. The data, as research is repeated with the persistence of a mantra, had been cross-checked, re-verified, and confirmed multiple times over. What's more, these signatures were discovered within an atmosphere that, it turned out, is composed of water vapor, methane, and carbon dioxide, the precise foundational triad essential for the emergence and sustenance of organic life as we know it. And yet, even when faced with such staggering and substantive proof, not a single official dared to utter that almost forbidden word: life. To acknowledge it aloud would mean shattering the comfortable spell of the old paradigm, a paradigm that had been carefully nurtured for decades by a cozy, lulling doubt. We are alone in the universe. The only problem is that now, it seems, the universe itself has begun to talk back. K2-18b is not a second Earth, not its mirror image in the cosmos. This world belongs to a transitional, entirely different class of planet. It is significantly larger and more massive than our home. Its mass exceeds that of Earth by a factor of 8.6, while its radius is larger by 2.6 times. The planet is classified as a Hycean world, a new, largely theoretical category that describes ocean worlds enveloped in dense, hydrogen-rich atmospheres. Its parent star, a cool red dwarf, bathes it in a dim crimson light. But the planet's orbit is fortunately situated within the so-called habitable zone, that narrow, precious belt where the temperature allows water to remain in its liquid state. Just imagine it. A boundless, profound ocean covering the entire planet, sheltered beneath a thick, protective atmospheric blanket, where conditions are more than merely permissible for the most complex chemical reactions. The very same reactions that, billions of years ago, sparked the genesis of the first life here on Earth. And this isn't just a fantasy, not some bold conjecture, but a detailed reconstruction based on the cutting-edge spectroscopic data from the James Webb Space Telescope. The information obtained was so crisp, so unambiguous that it demanded an entirely new interpretation. Science found itself facing an unbearable, excruciating dilemma. Either life exists there, 120 light years away from us, or our fundamental knowledge of the mechanisms behind planetary atmosphere formation is profoundly, depressingly deficient. Neither of these options allows for the preservation of our previous mental comfort, our cozy conviction that life is an isolated, rare, and perhaps utterly unique phenomenon. How can one even begin to reconcile with the idea that a planet so dissimilar and distant from our own is synthesizing the very same complex organic compounds without having the very same fundamental reason for doing so? Biology. In every leading university and advanced laboratory, from Cambridge to Caltech, the same question hung heavy in the air. Are we observing a completely new, hitherto unknown type of planetary chemistry? Or are we witnessing humanity's very first confirmed instance of an alien biosphere? The answers, though expressed with varying degrees of certainty, all converged on one point. Within the known catalog of geochemistry, there is absolutely nothing that could explain such a startling abundance of these specific molecules. And it was at that very moment that the old paradigm began to show its cracks. The true breakthrough, however, proved to be not so much scientific as it was symbolic. For the first time in all of history, the possible confirmation of extraterrestrial life did not trigger a wave of panic or widespread hysterical denial. Instead, a profound silence fell over the world. A reverent, tense, almost religious silence. Why do we invest billions in space exploration if, deep down, we are not striving to find the answer to this eternal question? And what will we do if that answer has already arrived? Micro-conflicts began to multiply everywhere. Scientists instantly split into two camps, the camp of extreme caution and the camp of restrained enthusiasm. Philosophers immediately began to debate the deep-seated meaning of this discovery for human civilization. Religious groups responded with a whole spectrum of interpretations, ranging from irrefutable proof of the omnipotence of divine creation to a direct threat to the established spiritual order. And society as a whole, for the very first time, came face to face with a question that could no longer be ignored or swept under the rug. What is most unsettling is not the existence of life beyond Earth itself, but its reflection, its echo. For if life exists elsewhere, and moreover, shares with us common biochemical markers, common molecules, it means that it is not a rare and fortunate accident, but a natural, inevitable consequence of the cosmos's very structure. The universe transforms from a cold, indifferent stage into a fertile, pulsating, and perhaps even, to some degree, a conscious organism. And this is where a question arises that begins to tear apart the very fabric of our modern beliefs. Are we ready to accept the fact that we are not the center of universal biology? And more importantly, are we ready to realize that we may be just one short chapter in a much longer, more magnificent book written by molecules, oceans, and atmospheres? K2-18b is inviting us to a unique form of contact. It isn't blinking lights at us or broadcasting coded radio waves. It simply is. It simply exists. And its very existence throws down a defiant challenge to us. Because if what we are observing is real, then the universe was inhabited long before our arrival. This is a cosmic reflection on Earth. When the news was finally confirmed, it circled the globe at the speed of light through the screens of mobile phones, internet forums, and podcasts. For one whole week, the abbreviation K2-18b became the world's top trend. This distant, dim planet managed to do what no global political or cultural event before it ever could. For one brief moment, it made the entire world fall silent and look at the same exact point in the sky. The eternal, almost rhetorical question, "Are we alone?" was replaced by another, far more uncomfortable and unsettling one. What changes now that we are no longer alone? At the SETI Institute, they published a formal, exceedingly cautious statement about the need for further observations. But behind the scenes, astrobiologists came face to face with the real, tangible probability that life might be a common, ordinary phenomenon throughout the universe. This idea, more potent than any fictional alien threat, delivers a crushing blow to human pride, which for centuries has been built upon the unshakable belief in our own exceptionalism. But now, the simple fact of a biogenic molecule appearing where, by all known laws, it should not exist, shatters that confidence at its very foundation. This is not just a scientific discovery, it is a civilizational shift, a point of no return. The reaction was truly global. In Kyoto, Buddhist monks conducted a special ceremony of cosmic contemplation, celebrating not the arrival of aliens, but the confirmation of the ancient idea of a living, ensouled cosmos. The Vatican officially stated that the existence of extraterrestrial life does not contradict Christian principles in the slightest and is an integral part of the grand divine creation. In Europe, they began to hastily revise school and university curricula to include courses on applied exobiology. And in France, leading philosophers and climatologists gathered for a conference to discuss how the discovery of distant biospheres impacts our own ecological behavior here and now. The reasoning was starkly simple and logical. If life exists elsewhere, then the value and fragility of life here on Earth increase immeasurably. The most unpredictable and profound effects occurred in private, everyday life. Teachers all over the world began their lessons with images of K2-18b, and students gazing at this distant world started asking deeper, more existential questions about their place in the universe. Artists created installations attempting to convey this strange sensation of observing something faceless, incomprehensible, yet possibly conscious. The number of internet search queries about extraterrestrial life surged by 640%. Culture began to slowly but surely adapt to a new reality where contact is no longer science fiction, but a statistical probability. And yet, amidst this universal excitement, a quiet, deep-seated melancholy began to grow. If life is indeed widespread, why is the universe so silent? The Fermi paradox took on a new, much darker shade. Perhaps the answer is that life exists, but it is predominantly microscopic. It doesn't build interstellar ships or send radio signals into space. It simply breathes, absorbs light, produces molecules, and perhaps evolves very, very slowly. The thought of our solitude has always been our armor, our cosmic alibi that justified our arrogance and our destructive attitude toward our own planet. But with the shadow of another distant ecosystem comes the realization of our cosmic responsibility. This silent world, hundreds of trillions of kilometers away, shows us exactly what we stand to lose. If life at a distance of 120 light-years is incapable of sending a message, then we are still the only ones in our known corner of the cosmos who can speak on its behalf, who can protect its history and preserve that thin, precious thread that connects carbon, time, and consciousness. And that changes absolutely everything. The reaction in scientific circles was surprisingly practical. The world's leading space agencies immediately reallocated budget funds, giving absolute priority to new generation telescopes like LUVOIR. Engineers proposed entire packages of upgrades for current missions specializing in the study of exoplanet atmospheres. The conversation was no longer about a vague desire to find something, but about the urgent necessity to observe with the highest possible precision to create a global system of cosmic monitoring, not for exploitation, but for preservation. Every click, every conversation, every article about K2-18b amplifies this signal, relentlessly expanding our horizons. The idea of life beyond Earth has ceased to be a curiosity or the domain of enthusiasts. It has become a new worldview, a new lens. And by understanding this, you are already participating in the greatest cultural experiment in human history, The acknowledgement that we are not the end of evolution, but merely one of many, many points on the map of being. This brings us to the most profound question, one that transcends the bounds of science and touches upon the very nature of reality itself. What if the universe itself possesses consciousness? If this thought resonates with you on some internal level, then you are ready for the next step in this incredible journey. A breath in the clouds. In March of 2025, scientists published a detailed, exhaustive analysis of K2-18b's atmosphere. What was supposed to be a routine publication of refined data transformed into a detailed chemical map of a possible biosphere. The spectrum of light absorption as it passed through the planet's atmosphere during its transit revealed not only the stable presence of dimethyl sulfide and methane, but also their distinct seasonal fluctuations. These small but consistent and cyclical changes, measured over numerous observations, bore a striking resemblance to the gas concentration fluctuations here on Earth, which are directly linked to the changing seasons and peaks in biological activity. In the absence of any convincing geological explanation, a silent question emerged among the experts. Are we observing the planetary breathing cycle of an alien world? All attempts to model this behavior using abiotic, non-living chemistry failed spectacularly. Not one of the more than 12 elaborate scenarios could reproduce the observed gas proportions without assuming completely absurd, physically impossible conditions on the planet. Alternative hypotheses, such as an exotic interaction between cosmic rays and the ocean's surface, would require the existence of an unprecedented, never-before-seen planetary chemistry, something that would be even more unusual and bizarre than life itself. This highlights a dilemma that extends far beyond pure science. Are we searching for familiar patterns and templates simply because of our inability to accept something entirely new? Systems biologist Jacques Darmel proposed that we are observing not just life, but the emergence of a living pattern, a self-organizing system with a complete atmospheric metabolism and cyclical regulation. In his view, the atmosphere of K2-18b behaves like a single, integrated organism, where the complex interplay between the ocean, the star's light, and chemical processes has created a cybernetic environment akin to a giant planetary lung. This provocative hypothesis, very similar to James Lovelock's Gaia theory, requires immense conceptual courage. But it is precisely such bold models that science now needs to explain this new, staggering reality. In the most audacious scientific circles, the idea of a so-called analogous biosphere is gaining traction. It suggests that planets like K2-18b are not exceptions, but structural repetitions, where the laws of chemistry, given the presence of liquid water and a light source, inevitably give rise to bioactive patterns. Computer simulations run on supercomputers have confirmed this unsettling probability. After analyzing hundreds of millions of possible atmospheric combinations for Hycean-class planets, the machines revealed that in 19% of cases, chemical profiles very similar to K2-18b emerged, and in 3% of cases, the system spontaneously transitioned into oscillatory cycles strikingly reminiscent of biological activity. These figures clearly indicate that K2-18b may not be a singular phenomenon, but simply the first well-studied case we have encountered. This cosmic repetition is disturbing because it directly attacks the very idea of human exceptionalism. What does it mean to discover that life might be a universal standard, not a miracle? Does it change the value of human life and the very ethics of space exploration? These questions go far beyond astrobiology, touching upon bioethics, philosophy, and a nascent interplanetary responsibility. Researchers are already overhauling the protocols for analyzing exoplanet data, and artificial intelligence laboratories are training neural networks to detect biological anomalies without relying on human biases and expectations. The goal is to create a machine that can recognize living patterns, even if we don't yet know what to call them. Let's imagine for a moment that by the year 2030, new generation telescopes confirm the existence of similar, breathing atmospheres on dozens of other planets. The conclusion would not just be life exists, but rather life is a cosmic vector, a fundamental structure of the universe. The focus of the scientific community would shift from searching for life to learning from it. But the most uncomfortable question remains unanswered. What is it like to live in a world where this answer has already been given, yet continue to act as if it hasn't? How do you teach science, politics, and ethics knowing that our reference points are no longer absolute? Meanwhile, the planet K2-18b continues its unhurried rotation around its star, possibly breathing, its clouds shifting in cycles we are only just beginning to faintly comprehend. The most unsettling thing is not what we see in it, but what it reveals within ourselves. Now that life is leaving its traces in distant atmospheres, a new, even more complex dilemma arises. Do we continue to simply observe from afar, or do we risk repeating the tragic mistakes of the past, to invade, to exploit, and to mindlessly interfere with something we do not understand at all? The price of looking too closely. When data points to something too large, too inconvenient to fit into our familiar narratives, it is often easier to ignore it. This is precisely what began to happen with K2-18b. After the initial wave of deafening hype, the news cycle returned to its familiar terrestrial problems, and the distant planet once again became a purely technical term for specialized scientific journals. But for the last 2 years, it has continued to send us signals. An expanded observation program showed that the density of water vapor in its atmosphere fluctuates in sync with the absorption of methane. On Earth, this is a sure sign of a complex interaction between the biosphere and the climate. However, in public reports, this critically important information was buried in footnotes and appendices under the formal pretext of insufficient statistical significance. At what point did we stop assigning urgency to something that could completely redefine our species? Within academic circles, however, the topic continued to be debated. An internal report from an interdisciplinary group at Cambridge University, which mysteriously leaked online in February of 2025, concluded that the probability of a non-biological origin for the signals from K2-18b is less than 1.7%. This is a level of confidence considered sufficient in clinical trials for the approval of life-saving drugs, yet this data was never officially published. Why? The acknowledgement of even microscopic alien life is not just a matter of science, but of national security, religion, and, most importantly, control over the global narrative. Equally telling was the stubborn silence from the European Space Agency regarding a joint report with France on thermal anomalies in the planet's atmosphere. The study identified stable zones with moderate temperatures, which completely contradicts standard climate models and points to the existence of stable internal heat sources. In the context of an ocean planet, geochemistry as a cause is ruled out, leaving only biology. However, in the official report, that term does not appear even once. Instead, vague euphemisms like non-uniform radiative activity were used. This fear of the consequences is nothing new. In 2001, after the discovery of possible microfossils in a Martian meteorite, NASA faced such a powerful wave of skepticism that it undermined confidence in any similar data for years. With K2-18b, the same story is repeating itself. We are witnessing a manifestation of cognitive bias on a planetary scale, a kind of institutionalized blindness that panics at the thought of confirming something that would demand a complete civilizational overhaul. An exception was an article by Indian researcher Rajesh Patel in May of 2025. He directly asserted that K2-18b represents the first discovered self-regulating chemical system beyond Earth, calling it a proto-Gaia, a planetary organism in its formative stage. According to him, the molecules we are observing are not just byproducts of life, but active components of a unified ecosystem in dynamic equilibrium. Simply put, the planet is alive as a system that breathes, reacts, and adapts. The scientific community's response was timid and cautious, but independent modeling based on Patel's theory showed that the planet's climate could indeed only be stable if there was some global process for organic carbon recycling. On Earth, marine life performs this function. What if the universe isn't silent, but is simply communicating in the language of molecules? And will we ever learn to understand it? The deepest layer of this discussion touches upon the ethics of the gaze. Since the first radio astronomy discoveries, the guiding principle has been, look, but don't touch. In the case of K2-18b, this principle is being severely tested. Planetary protection groups are already demanding the creation of cosmic quiet zones, where any artificial signals would be legally prohibited to avoid accidental contamination or disruption of developing biospheres. This is a radical inversion of the usual logic, to protect others from our impact. Not out of fear of them, but from a profound understanding that observation itself is a form of intervention. Human history is filled with examples where contact with new ecosystems led to their irreversible collapse. We are living in the moment of birth for a new interplanetary ethic, the realization that the universe is not a wasteland for colonization, but a space where life can emerge in ways we do not control and do not understand. The question is no longer whether there is life out there. That is becoming increasingly obvious. Now we must answer a different question. Are we worthy of finding it? A silence that breathes. K2-18b does not scream or send us complex signals. It simply exists, slowly rotating around its cold, dim star. Its atmosphere is filled with chemical compounds that, here on Earth, mean only one thing: life. We spent decades waiting for contact, imagining silver ships and voices from speakers, but instead, we found complex, organized chemistry, a pulsating atmosphere. We have encountered an uncomfortable, yet majestic truth. The universe may be full of life that has no desire to communicate with us because it simply doesn't need to. And for the first time in our entire history, we are not the main characters of this story. We are merely observers, and perhaps uninvited guests. The question is no longer whether we are alone, but what we are going to do now that we are no longer alone. To ignore this new reality is impossible. The data is there. The James Webb Space Telescope has thrown open a window for us onto a real, breathing world. And this is not just another scientific discovery. It is a shift in the coordinate axis of all humanity. K2-18b forces us to think of ourselves as a tiny part of a vast cosmic network that most certainly does not revolve around us. How many times has history shown that the most dangerous thing is not the unknown itself, but our arrogant inability to recognize it when it is staring us right in the face? Now the cosmos presents us with a completely new kind of presence. A life without a face, without a voice, but with an internal order, and perhaps with intent. On a personal level, this discovery is disarming. The cozy idea of a cold, indifferent universe where life is just a random fluctuation crumbles. What if life is a structural tendency of being itself, a process that arises naturally wherever the right conditions exist? This thought does not diminish the significance of Earth in the slightest. On the contrary, it elevates it, making our every breath part of an ancestral chain that did not begin here and did not begin with us. On a scientific level, new observation protocols and even the concept of exobiological conservation are already being discussed. Space is ceasing to be a place for conquest and is becoming an ethical territory. But the real rupture, the true fissure, is occurring on a civilizational level. If we admit that life is widespread, all our notions of exceptionalism collapse like a house of cards. The idea of being chosen loses its power, and that is truly terrifying. Governments do not know how to react. Religions are hastily redefining the boundaries of the sacred. Educators are searching for new words and images to present this new reality to children. Scientists, even with irrefutable data in hand, hesitate because anything that shatters a paradigm is rarely accepted without fierce resistance. The risk of ignoring the obvious is clear. To continue behaving as an isolated, short-sighted, and self-destructive species, destroying our own unique planet. But the risk of understanding is also enormous, for it demands a radical internal transformation, humility, disciplined curiosity, and the courage to face a reality that does not revolve around humanity. The question is not what exactly lives on K218b, but what this discovery says about the meaning of life here on Earth. And it is at this point that science meets philosophy. The detection of biosignatures is not a technical victory, but a call to rethink the very structure of reality. We have come all the way from molecules floating in space to the existential necessity of reevaluating humanity's role in the universe. Now that the data is in, ignoring it is no longer an act of innocence, but a conscious act of complicity in denial. You have heard the whisper of organic molecules in the eternal darkness. The question is no longer whether there is life out there, but what stands behind it. We are talking about something that goes beyond science and touches upon the staggering possibility that the universe itself possesses consciousness, not as a beautiful metaphor, but as a living, functioning system. If you have come this far, you are ready for the next step. This is not a search for simple answers, but a plunge into the abyss between what we are accustomed to calling reality and what the cosmos is trying to tell us. Now that you have seen this distant reflection, it is time to meet the mind behind it. If this investigation resonated with you, share it with those who still naively believe that the universe is empty and indifferent. Every great change in history begins exactly like this, with a world that demands to be seen, and with eyes that are ready to see it.